Okay, and here's number 15. Want to point out something really important. Highlight these words: constant positive acceleration. So a particle starts at rest at the point 2, 0 and moves along the x-axis with a constant positive acceleration for time t equal or greater than 0. Which of the following could be the graph of the distance or the position of the particle from the origin as a function of time t? Well, these are all your position functions. When you look at B and D and E, I hope that you notice that they're linear. Now, B and D, if they're linear, they're in this form. And when you take the derivative of that, y prime, doesn't really even matter what the equation is. But when you take the derivative of that with respect to x, y prime in both of those cases is going to be the slope, which is a number, a constant. That's the velocity, that slope value. So when we take the second derivative, y double prime is going to be the derivative of a constant, or 0. So these do not have constant positive acceleration because their acceleration is 0. Now for choice E, let me get rid of that menu. Choice E, this is the equation. And we can tell this right from the graph. Y equals 2. So when we do the velocity function, y prime, that's the derivative of 2, which is a constant, which is 0. And we can't even do the acceleration. Can't take the derivative of 0. So that one's not it. So we're left with A and C. Now, the thing to remember when you're looking at a position function on a graph is that T, and I'm going to emphasize this here, T is your horizontal axis. And it said that this particle, I'm going to grab my highlighter again, starts from rest. Now, rest means t equals 0. So that means you want A. This one is the one you want. If you look at C, the reason that you don't want C is because that's starting at t equals 2. So that's kind of what you're looking for. If you were confused between A and C, that's the reason. It starts from rest.